Good afternoon, everyone. In this video, we'll be talking about the special constructs for activity models. Activity diagram basic notation we have already seen. Okay. Activity diagrams have additional notation that is actually useful for large and complex applications. Okay. So as part of this video, we'll be looking at sending and receiving signals, and what are swim lanes, and what are object flows. So we have seen activity diagram in which like there are activities. Okay, so and then like the triggers basically like it is showing the control flow. Okay, but then like there can be situations where you may have to send and receive signals. Think about the example which I have shown here. Okay, so this is about rebooting a laptop. Okay, so the boot process of a laptop, for example, or any desktop which is in a network. So originally like your activity diagram starts here. Okay, and you basically have to execute a boot sequence. So you will start with executing the boot sequence. So once that activity is finished, you basically ask the user for the login and password, user ID and password. Okay, this is the activity which is happening here. That means like you will ask for it, and then like you will accept the user login. Once you have the login details, you basically have to send the login details to some network computer to basically verify them. Okay, so the user ID and password are to be validated, isn't it, by a network computer? So that's a signal which you are actually sending. Okay, so the request for validation, okay, validating that user ID, okay, the login credentials more or less, the signal is actually sent to the network. UML notation for sending the signal is this sort of convex pentagon. Okay, so this is convex pentagon. The moment like you actually send the signal, you immediately move to the next activity. So then you are actually waiting for the response from that network computer. Okay, so that the signal is actually received back. Okay, so after some time, like say for example, the network computer basically validates that user ID and password, and then like you basically receive the confirmation. Okay, that is the receiving the signal. This is actually a concave pentagon. Okay, so the concave pentagon. This is convex pentagon and this is concave pentagon. UML notations. So once you receive the confirmation from the network, you are basically ready. Of course, this is an activity diagram which is actually showing only the control flow, which actually works always. Okay, what happens if the user ID and password fails? Okay, so basically like you go back and then like you'll come back to this one, accept user login. Okay, that sort of guard conditions, and then like this diamond with multiple flows we have actually seen. Okay, multiple conditions being accepted. So this is how like you can actually send and receive signals in activity diagrams. Then the next concept is swim lanes. Swim lanes is also a very interesting concept actually. In a business model, it is often useful to know which human organization is actually responsible for an activity. Say for example, you have a huge activity diagram. Okay, and some of these activities are taken care by the finance office, finance organization. Some may be taken care by the sales organization. Some may be taken care by the marketing organization. How do you actually differentiate? So activity diagrams, basically we were showing like all the activities are happening, and one after the other the control flow is basically happening. But in certain situations it may happen like we also want to have the information of the organization that actually takes care of that particular activity. Then the basic idea is, so we can actually partition this complete activity diagram by dividing it into columns and lines. Each column is actually called a swim lane. Okay, and actually the lines again like the brackets basically. Okay, of course the lines which actually separate the swim lanes also will be there. Placing an activity in a swim lane actually indicates that it is actually performed by a person or persons within that organization. Okay, say for example by finance or sales or something. I will give you an example in the next slide that actually makes the things very clear for you. Lines across the swim lane boundaries actually indicates interaction within the organization, within an organization. Let's go and see an example. Here is a servicing an airplane. So assume like an airplane has landed the thing, and before it actually has to departure, go for the next departure, it has to be serviced. So the servicing an airplane actually involves, so we have to clean the trash, okay, and we also have to add the fuel, and we also have to load food and drinks for the next journey, okay. So the point is like in this case, the cleaning the trash is taken care by the flight attendant. So you can have this sort of swim lanes. So this is the swim lane which is for the flight attendant. The flight attendant in this case is taking care of the cleaning the trash. The ground crew is actually taking care of the adding the fuel, and the catering is actually taking care of this sort of loading food and drinks. In fact, actually, like this also this activity diagram, okay, this part of the activity diagram also has this sort of synchronization activity. So we have the merge uh, fork and merge here. Okay. So once the fork is happening, like all these three things are going on in parallel. So cleaning the trash, adding the fuel, and load food and drinks are happening, and all these three things are happening in different swim lanes. And after all the three things are finished, like you will come to the merge, join, and then like you will continue with the next activity. Okay. In this case, like it has this sort of synchronization bar. It don't even have to be a synchronization bar. I mean, like say for example, there can be an activity diagram where there are multiple steps. You can actually go from here to here, and then like probably go from there to here, and then from there to the activity comes here. It can also happen like that. And that's what we were discussing in the last point in the previous slide. So lines across the swim lane boundaries actually indicate the interaction within an organization. So how these different organizations within, I mean like different units within an organization are actually interacting and communicating among themselves. You can also see them, those things in this sort of activity diagrams. That's about swim lanes. Then the third topic of this video is this object flows. Sometimes it is actually helpful to see the relationship between the operations. The operations are actually performed on the objects. Okay. So the objects are actually used as these arguments or results from operations. So it is sometimes helpful to see the relationship between those operations and the objects on which like it is performing those operations. Okay. So there are provisions to show these objects also in the activity diagrams. Okay. So I will show you with this particular example in the next slide. Okay. But most frequently, some objects themselves go through several states during the execution of an activity diagram. So the object may actually go through several states during the execution. So each activity actually may move that object to a different state. And an activity usually produces or uses an object in a particular state. Okay. So that is what basically object flows basically show. Okay. So let's see them with an example. Again, let us think about the same airplane. Okay. The airplane basically, okay, so the airplane is the object here. That's why like this fallen airplane. And it can be in different states. It can be at the gate or like in taxiing state or in flight. Okay, so it can be in different states. Now you can actually, once you have this sort of activity diagram with this sort of object flows. So first like say for example that object airplane is at the gate. So then the activity can be like leave gate. Once you basically have this activity executed, which is leave gate, the airplane will be in the taxiing state. So it is ready to fly. Okay. So once the object is in the taxiing state, once you basically take off, the object will actually move to this in-flight state. So that means like it is in flight during the flight state. So after the takeoff is like the flight has taken off. So once this flight is in this flight mode, the object is in the flight mode. Once again, like it is landing. So the activity there is landing. Once you are landing again, then you are in the taxiing state again. Okay. So the airplane object is in taxiing state. And after that, like say for example, that plane has moved and then like it basically came to the gate, and the activity that is like park at the gate. You park at the gate. Then again, like the airplane will basically move to the state at the gate. So you started at the gate and you left the gate, okay, which actually moved into taxiing state. So then you have taken off, which actually put it into the flight state. Then you landed, again it put it into taxiing state. Then park at the gate will actually get it at the gate state. Object state is actually shown in this in brackets, square brackets. So the object and its state. So in this way, the activity diagram is actually unifying both the data flow and also the control flow. This may be advantageous in certain cases. Okay, so you should also be considering activity diagrams with object flows. So regarding the reference are concerned, like now we are in chapter 8. Okay, with this one, like chapter 8 is finished in object-oriented modeling and design with UML, Michael Blaha and James Hubbard. Thank you very much for your attention.